This is question number 51. It's an interesting problem with a person on a crutch. One of the more annoying parts of this one, though, is that they give us the weight of the person in pounds, not newtons. So first thing you want to do on this one real quick is just convert that. And so the conversion roughly gives us a 170 pound person is about 77, has a mass of 77 kilograms on the Earth's surface. Which means the force of gravity about 770 newtons. So we make gravity 10. Now here's where it gets interesting. Half of the person's weight is supported by the crutches, the other half by vertical forces exerted by the ground on the feet. And so that means half of the person's weight is being held up by a normal force here between the feet and the ground. And the other half is on the crutches themselves. And so now we get into the second part of this one, the smallest possible coefficient of friction between the crutches and the ground, and the magnitude of the compressive force exerted by each crutch. And I'm going to take a look at the point where it touches the ground. So here's one of the crutches. What do we know about one of these crutches? Well, it's got to exert an upward force on our person that's equal to half their weight. But don't forget that there are actually two crutches here, each holding up the person. One here and one here. So each of it only has to hold up half of the 385 remaining. So in this case, to 3 sig figs, each one's going to have to provide an upward force of 193. Actually, 192.5 for those who are like, wait, this doesn't add up. What other forces are acting at that point? Well, there's the force of the crutch on the ground this way, and there has to be a force of friction this way. What can we do at this point? Well, we can break this into its vertical and horizontal components. What do we know? If you remember, the angle up here on top, whoops, bad arrow. The angle here on top is also 22 degrees because it's 22 degrees up in the original diagram. And so if you combine the two sides, just using a little bit of trig, well, actually, before we do that, we know this vertical part here has to be 193 newtons. Why? The sum of all the forces must add up to 0. So this vertical component must equal that, even though I didn't draw them proportionally. And what do we know about this side? Well, that's got to equal the force of friction, a static friction in this case. So now doing our trig, if we know that's 22 degrees, 193 times the tangent of 22 will give us this opposite side, which should be about 78 newtons. The moment we know that, we know the force of static friction has to be 78 newtons to be able to keep this person up. If we use Pythagorean theorem or trig, you can also find this outside edge over here, or the hypotenuse, the force the crutches are providing. And that should be about 208 newtons. And that, by the way, is actually the answer to part B, even though we haven't solved part A yet. What is the compressive force on the crutch? The answer is 208 newtons. But what's the smallest possible coefficient of friction? That's the part we haven't solved yet. Well, if you remember, the force of static friction can range anywhere between 0 up to a maximum value of mu sub s, the coefficient of static friction, times the normal force. In this case, we know most of this. I'm going to drop, well, I'll drop the other part here just to avoid it. We know the force of static friction has to be at least 78 newtons, dropping units on here just to keep it clean. It has to be less than or equal to mu sub s, and we know the normal force in this case is 193. If you divide both sides by 193, you'll discover that our coefficient of static friction has to be greater than or equal to 0.04. And that's the answer to part A. It can be greater than that, but it can't be less than that. At 0.4, its maximum is 78, which is barely capable of keeping the crutch sliding out. If it's bigger than that, no problem at all. I hope that helped.